is the, as it says, open source app deployment system. It's modeled after Heroku. It's meant for deploying your apps and lots of them quickly, easily, using Python. We developed it at YouGov, which is my company. I'm executive technical director there, so I see the global development of about 4 development teams plus 3 others in different areas, but we're in Hong Kong, Warsaw, London, and all over the Americas with virtual developers. We're recently a top 25 research company. Our mission is gathering beliefs and behaviors from millions of people. So, although do we hit millions? We hit hundreds of thousands, pushing the millions globally. We send surveys out to people based on what clients need. Clients could be politicians, commercial companies, nonprofits, anybody who needs to know what people think. YouGov tells you what the world thinks, and we use that with data, good quality data, accurate data, and then combine that with expertise, good statistical analysis. This goes back to the 2000s. It was founded in 2000 when market research, they said you can't do this on computers. You can't collect data on machines. We do everything web-based data collection. So there's no telephone calling, there's no person-to-person. We do everything with an email that you respond to as a volunteer, as somebody who is interested. You come to the site and give your opinion. And using good statistical weighting, we can make good predictions about what our presidential elections are going to be or how your brand is going to do in the marketplace, among other things. We're heavily invested in Python. That's the reason I came to YouGov. I was at PyCon 2010, and I heard there was an opening. Bob Brewer, who maintains Cherry Pie, was there and recruited me. And this was my first opportunity to do Python full-time, and I was excited about it. So I took it, and I haven't looked back, and very happy about that. It also means that we're quite effective because of the speed of development we get in Python. The motivation for Velociraptor comes from the need to do repeatable deployments. So we had a little bit of that before, and I'll talk about that. But we want to be able to have a piece of code that gets deployed to one host and then is consistently deployed in the same way to other hosts, or that you can test in your dev environment and that same code goes out into production. It should be developer-driven, so we don't want to have a separate operations team that's solely responsible for application deployment. We want the barrier to entry to be so low that developers can go out and make things happen. That doesn't mean that it requires the developers to do it. There can be a separate dedicated QA team or however you want to organize it, but it's not opinionated about that. All it's opinionated about is that the simplicity of the application means anybody can use it, including the developers. It's meant to be language agnostic, so it works with Java and Node and Go, or any other application that you can make run on Linux. It is Linux-based. It's written in Python. It uses a number of Python technologies, including Django and Supervisor, and among other things. But its purpose is platform as a service. That's what PaaS stands for. So there are other PaaSes out there, and I'll be mentioning some of those as well. What we had before that was interesting. It was called Egg Monster. I don't know if that has some inspiration from where Velociraptor came from. Some things that YouGov get cute names in the background, but Egg Monster was what was in use when I came to the company, and I was impressed. My first week, I walked into the company, and they said, "As a developer, here's how you deploy our flagship application. Go ahead, try it." And I did, and I bounced the version of one of our applications. And rolled out a new version, rolled it back. It was super easy. It was command line based. I just had to, my mentor showed me a couple of commands, and voila, it went out and had it done. It used a technique from setuptools called multi-installed packages, which is largely deprecated in the pip model, but you can still use pip with eggs and use this model if you want to. But what it did is, instead of installing everything to easy-install.path, it would put the eggs out there in your site packages. It was using just the system site packages for everything, but they wouldn't get linked into syspath automatically, which means that your application wouldn't see any package unless it required one, unless it made a require call. And so what that meant is you could have many different applications on the same host, all with different requirements, and pulling in the ones that they needed when they started up. It used a central config server, so EggMonster itself had a event, a Pi event-driven event server that would listen for commands from the command line and send those out to all the different hosts and start up the appropriate applications. So you could start 1 or 5 or 10 procs of one application. It used YAML configs with nested hierarchies so that you could have config that applied to all of your applications, or some config that applied to just one application across all of your hosts, or specific config on specific hosts. It did violate repeatability, so this was the one thing that really pushed us away from it. So one thing that could happen is you would deploy your app, and it would be running fine, and then somebody else would deploy a different app with different requirements that would upgrade a package on that system. If you were then restart the original app, the first app, it might pick up that newer version of the application, unless you pinned all of your dependencies. And pinning dependencies has its own debt that comes with it, because then you have to update all your pins every time something needs to change. Not to mention you get software erosion. So over time your app gets older without picking up new things. So you couldn't easily update, you'd have to manually update. It had no GUI, it was command line based, so that limited the or increased the barrier to entry for some people. And it used fixed ports and manual routing. So you had to define the port in config that your proc was going to start up on, or a series of ports. It could use up to 10 procs. It could auto-assign a port with the last digit being assigned to each one. And then manual routing. So even though you had all your procs running, you had to go into the routing service and say, okay, now I want to connect this host name, this service name, to these different ports that I've configured. At the time, we were looking for alternatives, and we were looking at Juju, which was presented here at DC Python 4 years ago, or maybe it was 3. No, it would have been 4 years ago. It was called Ensemble at the time, and Canonical is still maintaining and using that. In fact, I just created a bug in path.py that Juju came back and said, you're breaking our stuff. So I fixed that. And Active State Staccato, which is still around, still maintained by Active State, and it's based on Cloud Foundry and now Docker, which is exciting to me. But we didn't invest a whole lot of time investigating these. We said, let's build our own. Okay, so we built our own. Our inspiration came primarily from Heroku, and specifically their 12-factor methodology. And if you're not familiar with this and you're interested in DevOps or deployment, don't miss this site. This tells you how to build good apps that can deploy easily and readily to multiple hosts. If you follow this methodology, then you can deploy to Heroku as well. It uses the same build packs. So Velociraptor uses Heroku build packs, which means that if it builds on Heroku, it probably builds on Velociraptor or very close. Same is true for some of the alternatives. And although it doesn't use Docker, it uses LXC, which is the underlying Linux container technology, which is a lightweight virtual machine technology that allows you to have your apps running all on the same host, operating system, even sharing the same kernel, but it can have everything else be unique. So your system libraries, your libc and your libevent and your XML versions can all be different. In fact, you can be running different versions of Ubuntu or Red Hat or whatever in your application, and it'll run independent of that. That was actually the second generation brought in container technology, and we did that because you find that over time, if you deploy a system into your ecosystem, you want to have a way to upgrade from one set of hosts to another. In the old days, you had to have different stacks. That's what Heroku did. They had the bamboo stack and then the cedar stack. Now they're going with the container model as well. So that's the way that an application can essentially decide what operating system I want to run under. And of course, Linux-based operating system. I should back up just a second about the reason we chose LXC was because of an implementation detail with supervisor, and I'll get into that more when I talk about it. So I mentioned that it uses Django. That's where it gets its GUI from. Our developer was who was primarily working on this was a Django fan. He says if he wrote it today, he'd probably write it in something more lightweight. But for better or for worse, it's using Django. It actually allowed, between Django and Bootstrap, had a nice visual appearance, and I'll demo it in a minute. Uses Postgres database to model the applications and the procs and the swarms, all the things that I'll talk about. And we also added a TastyPie API, so it can be controlled through an API. It also uses MongoDB for images and slugs. So images are those operating system images I was talking about that your application can be targeted to, and the slugs are your application as built. It's the thing that gets rolled out onto an image to run your application. It's the same terminology Heroku uses for the slugs they send when you build your application. Uses Celery, which is another Python tool for the workers to do the work. Supervisor D to host the processes, and then there's a CLI available. There are several key features to Velociraptor. Zero downtime deployments, which we did not have with Egg Monster. We depended on the fact that some of the processes would start up before the other ones would finish shutting down, so we would generally maintain uptime. Velociraptor guarantees it, and it guarantees it by supporting balancers, pluggable balancers. So your routing infrastructure, if it's Nginx or Varnish or Stingray, is supported out of the box with Velociraptor. So it will RPC or however control those routing services, and it will only do so once the updated service is ready to go. So your users will just be hitting your service. Over here we're standing up a new process. Users are still hitting the old processes. Once these are ready, it just switches them over. They're on the new version, and they're hitting this one. And then these get torn down. Manage config. So it manages your config. It uses ingredients, which are reusable config that can be specified in multiple swarms. And then, of course, you get repeatable deployments. It'll build and deploy the same things over and over again. So the platform is composed of all of these different aspects. The stacks and images, those are the operating system. The build packs, which are open source developed tools, build machinery for putting together applications of specific types. So there's Python build packs. We have a Python 3 specific build pack because the Heroku one that had a runtime in it had a lot of implementation details in it that violated our expectations. But you can build Go build packs. There's even a inline build pack, which will, it doesn't do anything except invoke your own application as the build pack at build time. So you can bypass the build pack machinery and just do a one-off in your application if appropriate. There are apps, which are the application, one per repository. Squads, which are the group of hosts to which you can target with an application. So in our ecosystem, we have a data center in Palo Alto, we have another one in London, and then we also have, so each of those becomes a squad that we can target with an app. We also have other ones that are specific. So there you have an application that has a characteristic difference. Maybe it needs more memory, or has a specific CPU requirement. So you want to send it to different hosts than you would otherwise. You can set up a squad and say, okay, this is a dedicated squad for such and such an application. The ingredients are where the config is stored. The builds are the things that once it downloads your repo, puts it together into a slug, it stores those builds. Releases are builds plus config. So just because you change your config doesn't mean you need to rebuild your application, so it decouples those two things. But when it puts them together, we call that a release. And then swarms are a bigger encapsulation of all of these things together. So it's a release, which includes build and ingredients, but also a swarm has its own unique config. It designates a squad to send that to, and that relates to the apps and the build packs and everything. So I'll show that in the demo. And so I spoke about a lot of this already. So the stacks the runtime environment. They use Linux images, so there's a base image that you can reference. You can basically get any LXC image from the internet. You can refer to one that's hosted by Ubuntu or Fedora or whatever, or you can build your own custom base image. But you also have a provisioning script. So it will automatically build this image for you, and then using the provisioning script, customize that image to create the stack that you're going to target. So tell it to install all of your favorite packages, your libxml and your Python dev headers, or whatever you're going to need in your stack, and that will be the basis, that will be the image that your application can target. And there's a GUI to facilitate that, so except for the script itself, you can basically invoke all of this to the UI. Build packs, like I said, were inspired by Heroku. It's kind of an industry standard. It has a fairly simple protocol. There's the detect, compile, and release steps. They're basically 3 executables that run in the bin directory. Detect is used so that applications can automatically detect their build pack. So if you see a requirements.txt and a proc file, so a proc file is a common thing in build pack. Oh, it must be a Python package, so we'll compile this with our Python build pack. And so you can put them in priority order, and then anyone that's detected as being appropriate will build that. Or you can explicitly say one, so the detect step is unimportant. But it supports essentially any number of techniques and languages. It supports repositories in Git or Mercurial. Originally it was only Mercurial because we were a Mercurial shop, but Git is dominant and needs support. So your app is a repository, a build pack, and the relevant stack. The squad is your pool of hosts, so you specify them by host name. They're specific to your deployment of this. They're meant to be commodity hosts, things that you're not going to be managing, oh, I want 3 apps to go on this host, I want 4 to go on this one. You want to be able to just treat them like commodity hosts and throw apps at them and let Velociraptor balance and make sure there's roughly equal number of procs on each host in the squad. So you want them to be identically provisioned, or near enough so. You don't want 16 gig of RAM on one and 8 on another, because Velociraptor is not going to honor that. Basically, anything within a squad should be identically provisioned, and preferably they should be co-located. There's nothing that requires that to be the case, but typically you expect a squad to be in a single location and managed separately. Maybe that's more of a requirement than is necessary. Like I said, the config ingredients are reusable config and YAML. The builds, like I said, are the build pack output. That's where the dependencies are frozen. So in the Python world, in the egg monster world, your dependencies could change over time. In this case, your dependencies are frozen. And so if you built something against a tag in your repository, and so we use tags to indicate which version of your app you're running, it'll build that at that point in time, and that freezes your dependency. So if you have a broad dependency and you build a week later, you might get a later version, because a later version was released. It's the whole slug except for the config, and that's what's combined with the config. Swarms, like I said, are primary target for Velociraptor, and there's a combination of all of those different things. It's a process within an app at a tag that has config, the ingredients, and the specific config that targets a squad and is routed in a balancer. And I mentioned the balancers before, the Nginx, Varnish, Stingray. They're pluggable and extensible, so you can write new balancer backends, and it'll support front ends as long as you balance it. Are there balancers that anybody's using that aren't one of these 3? That is, do they have an infrastructure at your company that routes to the public internet and isn't using one of these 3? AWS. So in that model, I guess you could use Nginx or Varnish, but yeah, it's not set up to do AWS. That would actually probably be a quite good one to do. We're actually expanding quite a number of our applications to AWS, and that would possibly be very useful. Okay, that was it. That was what I had for the overview. So I want to give a demo of it, because seeing is way better than me speaking. So. I first started, so when I put together this presentation a few weeks ago, I actually went through the documentation, and I'll give the URL at the end of the talk, but if you check out the code, it's actually right here. there's a README, and the README gives, actually the README now references the documentation. There's documentation online, read the docs, and it'll walk you through the entire process of setting up your own Velociraptor in a Vagrant virtual machine. So, doesn't matter, Windows, Linux, Mac, it'll get you started setting up a Vagrant virtual machine, give you all of the settings to set it up and be deployed with all of this infrastructure in a local environment. And moving that into production is fairly straightforward with the, of course, integration challenges around the actual application. But I thought what I would do is go to our production system. So I'm just going to VPN real quick into our network. Oh, come on. So it may be, I can't do VPN on this network. Nope, there we go, we're getting it, okay. All right, so deploy.yougov.net is our Velociraptor instance internally. Ah, the joys of live demos. I think it's loading. I imagine it's loading, and we're just on a slow network. I'm tempted to switch over to my 4G.
Leave harder.
All right, now I've got, let's see, I need to make this smaller.
Switch back to the Finder. It has fewer menus.
Aha. So I might be able to here go to. Come on, give me Kitsune. It's right here.
He thinks visual.
I try to put the Wi-Fi off and turn it back on. That makes it faster to find my phone sometimes.
Good call. There we go.
We're all laughing at that solution.
I could have brought the T-shirt.
We just thought it was a nice grab reference, right?
Oh, it's reconnecting, it says. Could it be that our network is actually down? Seems okay.
Well, you're not connected to the VPN yet, are you?
No, I don't think so. No, I had tested this earlier today. It was working. All right, well, that's a shame. Let's try the non-live demo. So I have here the Velociraptor repository checked out. And I should be able to Vagrant up. With any luck, this will start up the Vagrant machine I was talking about. What state it's in. It looks like it's starting from 0. One thing Velociraptor does is deploys its applications to ports starting at 5,000. It keeps track of which ports are assigned. It's something I've kind of wished we'd done similar to what Zookeeper did, which is use ephemeral ports, let the application bind to port 0, have the operating system assign a port, and then somehow get that port back to the system, such as Velociraptor, to let it know what port is being used. Okay, so now it's running Puppet, and so it's going to deploy a number of things, and yeah. So
Start
this
using Zookeeper and Velociraptor.
right.
Or SED, or...
So that's and I think we didn't go that direction mostly because we wanted the config to be bound to the build and sent with the slug. at least for the config part. But the port management, then we ended up kind of just saying, okay, well, let's just count up from 5,000. And that's worked for us. It's actually worked remarkably well. We've had a few conditions where Velociraptor would try to deploy to a port that's still being held by a proc because that proc wasn't torn down properly, but those were bugs, and we were able to clear those out. Supervisor.
So you still have to register with the port someplace, right? You still have to keep track of what you assign, right?
Velociraptor does that. So
Okay.
with it picks one, it gives it to that
Okay, well then that would
swarm
work
as
with the
it's going
ephemeral
out.
ports as well.
What's that?
That would have worked with the ephemeral ports as well, wouldn't it?
Except it chooses that before it sends it out. It chooses it in advance, and it even uses that number in naming the slug as it lands on the machine, which has advantages and disadvantages. One advantage is that you can now go to the machine and do a directory listing of all the apps there, and you can see what ports are going to be bound to. So if something's misbehaving on a port, you can just go to that host and say, oh, which app is using that port?
You could also use, Docker also reassigns ports and lets you query what it assigned.
Yeah. Actually, and that's one thing I think would be a good improvement for Velociraptor is Docker support. So I think it's probably in my advanced slides, and maybe I should go to those instead of
I thought you were using Docker.
trying to get to the. We're using LXC, the underlying technology. The reason we didn't go with Docker was because at the time it was opinionated about owning the process, and Supervisor likewise was opinionated about owning the process, and Supervisor couldn't operate effectively with Docker owning the process. One of the neat features about it, and I'm sad I'm not going to be able to show it, is you have your proc deployed, you can see the log of the proc in the web browser. Supervisor has an RPC service, and Velociraptor uses that to start and stop the procs, to restart them, have Supervisor restart them, but also to get the stream of events so that you can, oh, that thing keeps restarting. I wonder why. You just click on it right there in the UI, and there's your log and your errors that keep coming up. Because it'll restart, Supervisor will just keep restarting it, it'll keep failing, and you can see exactly why. It uses syslog. One of the concepts in the 12-factor methodology is you don't configure logging explicitly, you just log the standard out or standard error, and all of that is routed by the infrastructure. So Supervisor D does that for us. It takes the syslog, or takes the standard output, routes it to syslog, and then we send that to a centralized log server with a header on it that gives the Velociraptor details, so we know which app and everything was on it.
So how many nodes are you guys running Velociraptor across right now?
So we have probably a dozen squads. Our 2 prime squads are Ubuntu Precise right now, and they're about 10 hosts. Well, I'd say probably 20 hosts in London and 10 hosts in Palo Alto. And we're rolling out our trusty-based squads. I mean, just because we can now upgrade the infrastructure separately from our applications. So some of our applications are running on Trusty on a Precise host. We have other ones running in containers on these new Trusty hosts, and those are about a quarter of the size right now. As we move the applications from one squad to another, then we shrink the other ones and just add more hosts to the squad. I'd say there's probably 100 apps, and as many swarms. Well, probably 500 swarms. No, not 500. Maybe 250, 300 swarms. Okay, so this ran, and I'm not sure I can create a demo out of it. So if I go to the documentation, Velociraptor docs took me right there, which is great. If you search for just Velociraptor, you get dinosaurs. But if you search for Velociraptor YouGov or Velociraptor docs or Velociraptor supervisor, you'll get that. So there's pretty decent documentation here. And the development section is the one I was telling you about, the tutorial. that says how to get started from start to finish and have something actually running. Yeah, this takes probably 20 minutes, so I'm not going to run through it.
Did your VPN ever happen again?
It didn't. Well, yeah. I can try one more time. Come on. This is looking better. Okay. Aha! This is Velociraptor. So you recognize the common bootstraps theme. It's got the platform details up here, the things I mentioned before, the squads and stacks and build packs. The swarms, there are actually quite a few of them, so you have to search for a specific one. And so and unfortunately this low-res screen has put this into mobile mode, and so what we're seeing here is the event stream on the right-hand side. And actually I'm not seeing at all the procs, the apps, which should be on the left-hand side. That may be a bug in the UI. Oops. Ah, good idea. Aha, that's it. So on the left-hand side, you see the apps, and then a green square for each proc that's deployed in that app. So for example, here's our brand index admin, and this is the release indicator, the config name, production brand index admin. And here's how I mentioned, so you can click on an individual proc and you see the log of it, and that's updated live and streams through. You can also click full screen, get the log in full screen, but all the details about the proc, the release hash that was used, the uptime for your thing, so there's 21 days. So I've got this proc in here called dev.org. It's not particularly important, and I can stop it. And so now it's not running. If you go to the Stingray balancer where this has been routed, you'll get a 500 service not available. Start it back up, it'll find it again. If I want more of those dev.org processes, I can simply go to Swarms, look for dev.org. And so you notice it's got version 201. That's just a tag in the repo. You can use semver tags, you can use naked version tags like this one, or you can use any tag at all. In fact, you can even use the hash of the commit in the repo as your tag, and it will check out that version of the code and deploy it. I'm not actually going to change the tag or the config, but I am going to change it from 1 proc to 5. And so I just changed the 1 to a 5, hit swarm. It's going to go and say, okay, I need 5. How many do I have? I have 1. I need 4. So it's going to take 4 more, roll out the same build and release that it's done before in 4 new places. And so that's what it's doing right here. It's rolled out 4. It's found that there are no up tests, so it goes straight to routing it in the balancer, and it's finished the swarm. So now in dev.org, I see I have 5 instead of 1. And shrinking the number. So there's your load balancing. When you have a burst of capacity that you need, you just create more of them. Changing the config is also similarly easy. So I believe dev.org does not use any config ingredients. It just has swarm config right here inherent in the thing. Here's the config YAML, but let's say I don't want to change the config YAML, I just want to change an environment variable. So Python, DC Python. So there we go. We got YAML to create an environment variable, and I don't want 5 procs anymore, I just want 1. So go ahead and swarm that to 1. Now, if I hadn't changed the config, it would just delete 4 procs. Because I have changed the config, it needs to create a new release. It's going to roll that release out, make sure that that release is safe. Now, there are no up tests. And we got a 500 error. That's That's a beautiful error. It means that I did something wrong in config. It's probably that exclamation point and is not valid YAML.
I mean, what does no uptest mean?
Okay, so uptests are actually a really powerful feature of, and how am I doing for time? I think I'm over, aren't I?
A little bit. I don't know, I'll keep going for a minute or two.
Cool. So I'm in Keynote, but I don't see my slides. Maybe I have to be back. Well. Is there a reason? There we go. So there are a few advanced topics I want to talk about. Uptest is actually a good one. So I mentioned the getting started. This is a great thing. It also has a test suite that runs in PyTest. Some notes on production deployment. I did want to mention alternatives because I don't think Velociraptor is necessarily the best, state of the art out there. In fact, active state staccato still looks very attractive to me. Google has a thing called Kubernetes. I think it's Kubernetes because it's meant to be cube something, but maybe it's Kubernetes. Ansible Tower. So Ansible is a deployment system. Ansible Tower does more of this bigger management aspect. Gilliam and Suru, I'm not even familiar with. I added them here because I found them in my searches. And OpenRoku is, Heroku that's open. I didn't write about uptests. Okay, uptests are actually a really cool feature. So, everybody tests their code in development. They test their code in continuous integration, and maybe they even use that to do continuous deployment. And you can do that with Velociraptor. You could have your Jenkins host, for example, invoke the swarms through the command line interface or through the API. What uptests do is something very special, which is make sure that the code that got built on Velociraptor is viable, that it meets certain basic criteria, that it's listening on the port, that the service endpoints are functional, that they're responding to certain things. They're arbitrary uptests. You can write as many as you want, and they're just basic executables that get past the port and host on the command line. So host and port in that order, and then you can do arbitrary tests against that particular instance of your process. So anytime a swarm is invoked, it sets up the new procs, subtracts them, deletes them, but then it runs the uptests on each one before it does anything. So when I was talking about your application's getting hit over here, and you stand up these new procs, if one of those is failing, and then you switch everybody over, well, now they start getting failure messages. This says here are some basic sanity checks that you can make on your application. You can even do things like cache warming. So that's one thing we do in one of our applications. We've got panelists hitting this over here. They're just hammering it, and if we just switch them over to these cold procs, they're going to get a slow response. It's just going to fall over, for about 15 seconds until all the caches warm up and the procs catch up with the activity that these old procs were doing. So what we do is we query the database to say what's active right now. Let's load all that into memory. We do that during the uptest, so that now when the routing happens, it's as if nothing ever happened. And so we can just deploy willy-nilly any time of day, Friday evening, Saturday morning, doesn't matter. We have great confidence that our applications will be viable when we deploy them. Now that doesn't mean that it's foolproof. Obviously you have to write the uptests. So you are making your own guarantees, but it gives you the chance to do that. Yeah.
Have you done any work like doing the monitoring for error rates so you could back out a deploy if it suddenly goes up?
So that is actually probably one of our top requested features, is that we have a way to back out a bad deploy automatically. We don't. Now, one thing, and partially we don't, is because Velociraptor makes it so easy to do manually. So you've just rolled out a new release, maybe you've changed the config variable, you can change the config and the release back, and it will reuse the same build you had before and the same config. Config is a little bit harder. It doesn't manage a history of config, so you can't say give me a config from the past. That would be a nice feature to have. In fact, we've got all these releases that we've saved. There's no reason we couldn't grab a release and say use the config from that one, but there's no feature for that. But as far as, I just rolled out a new version, now I'm rolling back. It's just type the tag in, swarm again, and you're golden. so that's, we still manage that manually, but that would be nice to have. Were there any other questions?
When you say you lower the number of nodes you're deploying to, what does it do to live connections?
So
Live requests.
Velociraptor is stateless, with respect to the balancers. So it doesn't keep track of what was deployed before. It just routes the procs based on what it knows now. So let's say you were to take some hosts out of your squad. Those hosts will continue to run the procs. They will still continue to be routed by the balancer. So what you have to do then is reswarm, after making that change to the squad, reswarm any relevant procs that were on those hosts. And you can do that by going to the UI and say, what procs do I have on these? And reswarm all of them. You could write a script for it if you've got a lot of them. And that will cause them to all then be rebalanced to the ones that remain in the squad.
Yeah, but what about in-flight requests on the ones that were already handling requests?
So we rely on the balancers to handle that. So in-flight requests will be, we use Stingray because that's the infrastructure that we inherited, but Stingray will keep those connections and continue to allow them to be hosted for about 30 seconds, at which point then they get torn down. So we try not to have processes that are long run that are managed through this, which is something not all the databases support that. The ability to, for example, hand off your cursor to something else if you've got a cursor that's going to take 2 hours to traverse through. And so processes that do that, they just fail, basically. And then we have detection mechanisms to restart whatever operation it was that was long running. Yeah.
Could you chain together two different Velociraptor environments to have one of them act like your continuous integration phase and the other one your deployment phase?
I suppose you could.
Would there be a reason? The environment I'm in, we use Circle CI to our CI, and we use Heroku to do the deploy.
Yeah.
And from the outside looking at them, actually the lines are kind of starting to blur in terms of what those services are actually providing to me. I'm just getting VMs that I can script and configure.
Yeah.
Right? And so you're describing something to me, it sounds like I could get Velociraptor to do, even if it's up tests, become my CI validation step. And if I can get it to talk to itself then to do a deploy, I've eliminated one entire category of separate service.
That's interesting. I hadn't thought about it, but I suppose that's possible. Yeah, we do our our staging and production environments through the same Velociraptor instance, but we've only ever had the one. I did have a link. Oh yeah. Yeah, I just wanted to leave that up at the end, which was the repository, which is just Bitbucket, YouGov, Velociraptor. So that's the root of everything. That'll get you to YouGov. That'll get you to the docs. That'll get you to the repository. Get you set up on Vagrant. So if you want to check it out, it's completely open source. We welcome contributions, and so feel free to try it out. Send me your comments, file issues, bugs, whatever. There are quite a few open issues as well. If there's something you want to tackle on it, you can invite that as well. But with that, that's Velociraptor.